teaching you how to differentiate by the quotient rule. And the quotient rule states that dy dx is equal to v, which is the denominator, times the differential of the numerator u, from u, which is the numerator, times the differential of the denominator v, all over the denominator square, which is v square. So first is going to be dy dx equal to 1 minus cos theta, close bracket, open bracket, minus theta cos theta plus sine theta times minus 1, close bracket, minus open bracket, minus theta sine theta times sine theta, close bracket, all upon 1 minus cos theta all square. The next step, all you need to do is multiply our brackets. So it's going to be 1 times...
Hold on though, I got a question. No. I got a question. How come the numerator is so big?
The numerator? Oh, the reason being the numerator is so complicated. I won't say complicated, but big is because there is a product in the numerator. So you have to, since this is the formula, you put the denominator times the differential of the numerator, and since this is a product, so you have to treat this as a product. You have to differentiate this as a product. So it's going to be the first term times the differential of the second term plus the second term times the differential of the first term. So the next step, all you need to do is multiply our brackets, and so it's going to be 1 times everything in this bracket. So it's going to be minus theta cos theta, 1 times minus sine theta, because notice that there's a minus 1 here. It's going to be minus theta, minus sine theta, sorry. And this minus cos theta is going to multiply everything in this bracket. So it's going to be minus theta times minus theta cos theta will give you positive theta cos square theta plus cos theta sine theta. And this bracket, since you have two signs here and two like signs also here, is going to be plus theta sine square theta all upon 1 minus theta square, 1 minus cos theta all square. At this point, all you need to do is group like terms. So we're gonna put this back here, group the squares, and group the sign with this term here, all upon 1 minus cos all square. At this point, as you can see, I factor out the theta, because theta is common in both terms. So I factor out theta. So it's going to leave it theta square, cos square theta plus sine square theta. And as you can see, sine is common in both terms. So I factor out sine. Note, I bring down the negative sign here. So I factor out sine. So it's going to be 1 minus cos theta, all upon 1 minus theta cos theta r square. At this step, you need to factor out, you need to use the trigonometrical identity, which is cos square theta plus sine square theta minus 1. So since cos square theta plus sine square theta is equal to 1, therefore 1 cos theta times 1 is equal to theta, as you can see over here, which is sine theta minus theta cos theta plus theta minus sine theta, open bracket, 1 minus theta, 1 minus cos theta, close bracket, all upon 1 minus cos theta all square. Since theta is common in this bracket here, Also, you can factor out theta here. There's going to be theta, open bracket, 1 minus cos theta, close bracket, and I write back the same term here. All upon this term r squared. And at this point, you can see there's two common terms here, so again you can factorize. So it's gonna be this term times the term that is remaining, which is theta minus sine theta, all upon this term squared. And since these two terms are multiplying each other, and there's 1 minus cos theta r squared, which means there's two of this term. You can cancel out one of this term with one of this term. So it's gonna be, so dy dx is gonna equal to theta minus sine theta all over 1 minus cos theta. And that's the end of the problem.
Woo!